Hey, what's up, everybody, and welcome back to the Sanctuary. I'm your host, Professor C, and today we'll be talking about anatomy and physiology. Specifically, we're going to do another big test. Test yourself number 2 over all of the chemistry material. So buckle up and let's get in it. I think there's 31 questions here, multiple choice, so let's get to it. Choose the statement that is false. All right, let's look at them one by one then. Exergonic, what does that mean? A release energy. Okay, exergonic reactions release more energy than they consume. That sounds reasonable. Endergonic reactions consume more energy than they release. That sounds reasonable also. So those are two true statements. We're looking for the one that's false. Exergonic, again, release energy are associated with bonds breaking. That is true too, because we break a bond, energy is liberated. Well, I hope the fourth one's false, because all those are true so far. Endergonic reactions are associated with bonds breaking. Nope, that's wrong. And that should be it. And we got it right. In general, the types of lipids referred to as oils. Okay, remember, oils are liquids. So this is probably having something to do with wiggly tails and levels of unsaturation. So oils have very high water content. No, sir, oils and waters don't get along at all. That's not true. Long fatty acids. They do, but I don't know if they're any longer than any normal other type of lipid, right? A higher amount of saturated bonds. No, they don't. They've got a higher amount of unsaturated bonds because they have floppy tails. I hope that's the last choice. Yep, a higher amount of unsaturated bonds. That gives more flexibility to the tails and the substances become more liquid. The genetic information is coded into the DNA by the, let's see what they're getting to here. By the repetitive alteration of sugar and phosphate. Nope, sugar and phosphate just make up the backbone of the DNA. They don't actually have any information, and the information is encoded by the bases, right, that stick out, the G's, A's, T's, and C's. The sequence of nucleotides. So that's what really holds the genetic information, is the sequence of them. Structure of the double helix, that's a little too generic to be the best answer. And the amount of histone proteins. Histones have to do with packaging DNA while we're doing cell division, so that is not the answer either. It looks like we were correct when we said it's the sequence of nucleotides. It's the bases that really matter, but that is true there too. Which of the following statements about proteins is false? We're looking at proteins, false statements. They could be denatured with heat or acidity. That is definitely true. They can be denatured, so that's not what we're looking for. It's a true statement. A major class are enzymes. Yeah, a major class of proteins are enzymes. True. So that's not our answer. They are molecules that code hereditary information. Nope, that's DNA. It used to be thought a long time ago protein was the info molecule, but we know today that DNA is the info molecule. So that's false. I'm going to go for that being the answer. Let's hope D is an actual true statement. Their function, protein function, depends on their 3D conformation. Yep, that's true. So C is the only false one there, and that is the correct answer. Okay, carbohydrates are stored in the liver and muscles in the form of glycogen, right? One of our polysaccharides we learned. So let's just look for glycogen and be done with it. Glucose, no. Cholesterol, no. Triglyceride, no. And there is glycogen. We got it right. Catabolic reactions are usually associated with, now this could be several things, so we know before we even look. Catabolic will break. Catabolic will release energy because we're breaking bonds. We're releasing energy. That's exergonic. Let's see if we have anything like that. The release of energy. Yep, they do that. That is true. Is that our answer already? The consumption of energy. Nope, that's the opposite. That's wrong. is associated with synthesis. Catabolism is not synthesis. Synthesis is making something. That's anabolism. So catabolism is not synthesis. And again, synthesis is building polymers, so that's not catabolism. Catabolism is breaking. So A is the only possible true answer there, and it is correct. Salts are always delicious. I don't think delicious is going to be one of our choices, though, so let's check it out. They are always ionic substances. That's true. They are. Substances which ionize in water. That is true. Let's see if that is our answer. They're formed with covalent bonds. No. Salts are formed with ionic bonds. Formed with double covalent. No, that's even worse, sir, of an answer, right? They're formed with ionic bonds, not covalents at all. And then hydrogen bonding, nope. So this is just basically asking you, do you realize that salts are ionic compounds held together by ionic bonds? Yep, and that's correct. The numbers listed below show the number of electrons in the first, second, and third shells, respectively. Ooh, tricky one here. I might have to draw something. Based on the following info, which of the following atoms are unstable? Okay, we definitely need to get into this one a little more. Let's get a pen going. All right, let's see some numbers already. 2 and 8. Okay, so again, first and second. Let's draw that out real quick. We don't care about the nucleus so much, but 2 in this one, and then 8. I'll just draw them like little hash marks to make it quicker. That's stable, right? That would be a full valence. 2, 8 would be stable. So that's not it. We're looking for the unstable ones. 2, 8, 8. Well, we could just take what we just drew, 2, 8, and add a third ring to it and put 8 here. And that would be 2, 8, 8. But we have the same situation. We have a full valence, so that is stable. That's not the answer. 2, 0, 0. Well, that's very simple too. We draw the nucleus, we put 2, and then we don't need anything else because there is no second, there is no third shell. So 2 in the first is actually full. So that's another stable atom. Let's hope and pray that the last one is unstable, right? Or we've done something wrong in our thinking. 2, 8, 2. So nucleus, we put 2 in this one, 8 in the second one. 1, 2, 3, 4, 5, 6, 7, 8. And then 2. Aha, there we go. That is definitely an unfull valence. It is unstable. That is correct. A solution as a pH 2 would be best described as, and again, if it's below 7, you would say that it's acidic first thing. So let's see. There it is. There's our answer. It's best described as acidic. I would almost stop there, but let's make sure we're not getting tricked. Alkaline, nope, that's the opposite. It's got to be over 7. Neutral is exactly 7, so that's not it. And basic is the same as alkaline. So acidic is the only answer that could be correct there, and it is correct. Which of the following could be regarded as organic? And remember, we know what organic is. It's either carb, lipid, protein, or nucleic acids. So let's hopefully think it's one of those. H2O. Water is not. Water is inorganic. It doesn't have any carbon. NaCl, table salt, right? Sodium chloride doesn't have any hydrogen, doesn't have any carbon, so it's definitely not organic. NaOH, one of our bases we learned about, sodium hydroxide. Again, no carbon. It does have one hydrogen, but it has no carbon, so it's not organic. None of those are hydrocarbons. None of those are organic. So the last one here, CH4, even though it's methane, if you knew that, you'd think that's not organic. Sure it is. It's a hydrocarbon made of nothing but C's and H's. So that is our correct answer. What is an unfolded short chain of amino acids called? We don't call it a protein yet until we fold it up and make sure it's long enough. Until then it's called a polypeptide. So let's find that word. Nucleotide? Nope, that's a DNA word. Protein? Not yet. Not if it's unfolded and short. Polypeptide? Winner, winner? And a starch is a carbohydrate, is not made of amino acids. So polypep would be our answer, and we win that game. What level of protein folding is characterized by the coiling of polypeptides into an alpha helix? All right, so we know that if I see an alpha helix or a beta pleated sheet, that is the second level of protein folding. Secondary, so we're looking for second or secondary, something like that. Primary? Nope. Secondary? Yep. Tertiary? Nope. Quaternary? Nope. So let's see it. Drum roll, please. Boom, boom, boom. And that's beautiful. Got it. Carbs and proteins are built from their monomers by, It's saying, okay, if there's some carb monomers and protein monomers, and we're going to build up a polymer, they're probably going to be built by some sort of what's called anabolism or dehydration synthesis. Is what I'm probably thinking right now before I look at the answers. Let's see. The addition of water. No, if we add water, that's called hydrolysis, and it breaks something. So we're not going to be building anything by adding water. The addition of carbon between, no, that's a silly answer. We didn't talk about that in any way, shape, or form. It's a bogus choice. The removal of water. Aha, there we go. We know we can do anabolism. We know we can do building from monomers by dehydrating the system. So dehydration synthesis. That looks like a really good choice. And the addition of nitrogen between each unit. No, that doesn't make sense at all either. So we hope it's C because that's the only one that is logically correct. And it is. What happens during a redox reaction? Remember we had this relay race. Let's kind of sketch this one out too. We had substance A and substance B, and they were runners in a relay race, and they were going to be passing a baton that's actually electrons. And so remember, if A passes and donates it, he's being oxidized. And if B is picking it up, he's being reduced. An electron acceptor is reduced. Well, who's our acceptor here, right? Well, that would be B. B is accepting the baton. It's taking it. And it is being reduced. That's true. Could that be we found our answer already? Let's see. An electron donor is reduced. So that's substance A. A is donating the electron, and he's not being reduced. He's being oxidized. So that's not it. An electron acceptor is phosphorylated. That does not have anything to do directly with the redox reaction. That's a false answer. And then an electron donor is phosphorylated. Again, a false answer. This has nothing to do directly with phosphorylation. So we hope the answer is A, and it was the first choice that came off the pile. Which of the following statements is correct? We're looking for the true statement here concerning nucleic acids. There are three major types: DNA, RNA, and PNA. What the heck is PNA? That's got to be a false. Remember, if you haven't heard of it, don't pick it on the day of the test, right? DNA is a double-stranded molecule with bases G, A, U, and C. All of that is correct except for the letter U. And we know we only find a T in DNA. The U is found in RNA, so that's not correct. It's almost correct. RNA is double-stranded. Well, we can stop right there because we know RNA is not double-stranded. It's single. They got the bases right, GAUC, but it's only single-stranded, one backbone. DNA is a double-stranded molecule, yes, with bases GATC. Now we got all of it correct. That better be our choice. And it is. Where'd everybody else go? Come back. There they are. Which of the following statements is correct concerning isotopes? Remember, it's a good thing to write down too. They have the same proton number or the same atomic number, but different neutron number or a different atomic weight. So look for something that says that. All isotopes of an element have the same number of neutrons. No, that's what makes an isotope is a differing number of neutrons. That can't be it. That can't be correct. All isotopes are radioactive. No, they're not. Some are, but no, not all. So that's not it. isotopes are only found in large atoms? Nope, that's not true either. In fact, our example in class, or on my lectures, I think, was hydrogen, which is the tiniest of all the atoms. If hydrogen has isotopes, then it doesn't have anything to do with the size of the atom. None of those are correct so far, so hopefully the last one is. All the isotopes of an element have the same number of protons. That is true, and we even wrote that down right there. They all have the same number of protons. Got it. Wonderful. Where'd you go again? Okay. Which four elements make up 96% of all? Well, CHON, right? C, H, O, and N. But remember what they stand for. Carbon, oxygen, hydrogen. Not any other thing that starts with an H. Sometimes I'll try to trick you. And nitrogen. So I see CHON, but there they've tried to trick us with helium. Yeah, it starts with H, but it's the wrong one. It should be hydrogen there, so that's not it. CHON, no, they got calcium in there instead of the O. That's wrong. And that one's just completely bonkers. It's not CHON at all. There's two of them missing there. And finally, at the bottom, we've got all four. CHON and H is actually hydrogen. So that should be our winner. And it is. Atom Z has an atomic number of 66. What does that tell us? That tells us it has 66 protons. That also tells us it has 66 electrons. It doesn't say anything about an atomic weight. It doesn't tell us anything about neutron number, though. So which of the following statements are correct regarding this atom? Let's see. It has 33 protons and 33 neutrons. Nope, we said it's got 66 protons because that's what an atomic number is, so that can't be right. It has 66 protons, 66 electrons. That's exactly what we wrote a minute ago. So that's got to be it, right? Well, let's look and see. It has 132 neutrons. What the heck? That makes no sense. I know that's 66 plus 66, but no, sir, that has nothing to do with neutrons here. It has a mass of 66 AMU. Well, it wouldn't have that. We know it would have some neutrons, and it would have a mass of greater than 66, because I know there's 66 protons plus all the neutrons, but it wouldn't be exactly 66. So our answer is the one we wrote originally, 66 and 66. Atom Y has 17 protons. How many electrons should be found in the valence shell? We'll sketch it out real quick. You put the nucleus here, we don't really care because we need the number of electrons, and we know that there's 17p, so there's going to be 17e as well because we have a balanced atom here. So 17, we need 2 electrons here, need 15 more. So put 8 here, right? That gives us 10 total. We're still lacking 7. And those can all fit in the last shell, so I'll just cheat and put 7. 7 should be our answer. That's how many electrons are in the outer shell. 7. Nope. 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 Yep, there's 7. And let's see. We got it. What does the chemical formula C6H12O6 tell you? Well, it tells me a lot of things. It's got 6 carbons, 12 hydrogens, 6 oxygens. It tells me it's a hexose. It tells me it's a sugar. There's a lot of things I can tell about it from studying it, but let's see what our choices are. This molecule is made of 6 calcium. No, not 6 calcium. The C stands for carbon. This molecule is made of 6 carbon, 12 hydrogen, and 6 oxygen atoms. That is great. That sounds perfect. Let's see if there's one better. This molecule's mass is 24 AMU. No, we're not even going to go there. That's way incorrect. This molecule is made of 24 smaller molecules. No, that's not correct either. So the one that we thought made sense for a reason, because it's the correct answer. An atom with 3 valence electrons might have a total of how many? Ooh, this one's tricky too. It could be an instance where it has, 2 in the first and 3 there, and that could be, that's definitely 3 valence electrons with 5, so 5 would work. You could have a situation where you had 2, 8, and then 3, right? That would give you 3 valence electrons. That would be 13. 13 would work. Well, so would, 2, 8, 8, and then a 3 out here. 16, 17, 18, 19, 20, 21. So it looks like those are the winners. Let's see what we have for answers. 3, no, that's not 5, 13, or 21. 8 is not 5, 13, or 21. 17 is not 5, 13, or 21. But D is 13. And that would be one of the combinations where we could end up with 3 valence electrons. So we win that game as well. Which of the following is a neutralization reaction? All right, remember, a neutralization took an acid and a base, and it didn't double exchange and created salt water. And I only see one thing there that shows acid, base, and salt water. So that has to be our answer. And it is, even though that was a bit janky. That's our answer. Like for salt water, that's going to be the ultimate goal here. In chemistry, the symbol that shows what? 0 equals 0? No, it doesn't. Well, it shows oxygen and an oxygen in 2 straight lines, probably showing covalent bonds. So I'm going to guess it's showing oxygen with 2 covalent bonds, not 0 equals 0, right? The 2 oxygen atoms held together with 2 hydrogen bonds. No, hydrogen bond would be dashed lines, and these are solid lines. So the 2 oxygen atoms held together with a double covalent bond. That sounds great. I don't see just one line, I've seen 2, so that's a double covalence. 2 oxygen atoms are held together with a double ionic bond. No, that's not the way we write ionic bonds. So the answer will be C, and we win again. What does the symbol CH4 tell us? Okay, we got a carbon and 4 hydrogens. It also tells us it's a hydrocarbon, or organic, because it's only made of C's and H's. It was made from a redox reaction. We have no clue that that could be true at all, so that's a bogus choice. It contains 4 hydrogen atoms and 1 carbon atom. Yeah, it does. That sounds great. Let's hold that in the back for a moment. It is inorganic. No, it's organic all the way because it's made of C and H, right? It's a hydrocarbon. And it contains 4 carbons and 1 hydrogen. No, they got the numbers wrong there. B was the answer. It has 4 hydrogens and 1 carbon. Amino acids joining together to make a polypeptide is an example of, okay, we're building something. We're taking individual amino acids and we're building them together. So that's either going to be anabolic. It could be described as synthesis or dehydration synthesis even. Let's see what our choices are. Synthesis right off the bat. That looks like the winner right there. Decomp is breaking, so no, that's not it. Neutralization has to do with acids and bases and salt water. That's definitely not it. And catabolism is a breakdown also, like decomp. So A is the answer all the way. Which of the following is not an electrolyte? An acid is. We know acids, bases, and salts are all electrolytes. So an acid is an electrolyte. Sodium chloride is a salt. We know salts are electrolytes. Water, no, water is not an electrolyte. Water can cause chemicals to dissociate into electrolytes, but water itself is not. And sodium hydroxide is. It's a strong base. So the answer would be C. Water is not an electrolyte. Which property of water is illustrated when we sweat? We talked about this specifically. That has something to do with evaporative cooling, right? So look for the word evaporate somehow. And there I see it, a high heat of vaporization. That's going to be the answer. Sucrose is a, well, it's a sugar, right? It's a carbohydrate, But we memorized a few things, and we know that if we had glucose and fructose, two monosaccharides, they can chain together and make a disaccharide, which is sucrose. So that's what I'm looking for first. Mono, di, there he is. B, I'm thinking B's the answer right away. Polysaccharide, try it. No, it's definitely B. And we win again. What is the ratio of fatty acids to glycerol in a neutral fat? Okay, a neutral fat is a triglyceride. And remember, triglyceride is made of 1 glycerol to 3 tails. So what's the ratio of fatty acids? 3 to the glycerol, 1. It should be 3 to 1. If it asks what the ratio of glycerol to fatty acids, it would be 1 to 3. But it's asking you for the ratio of fatty acids to glycerol, 3 to 1. 2 to 1, nope. 1 to 3, no, that's the opposite. 3 to 1's the winner, and 1 to 2 is not. So I'm thinking C, definitely. And it is the answer. What role does phosphate serve? Remember, in DNA, it was sugar, phosphate, sugar, phosphate, sugar, phosphate made up the backbone, and the bases stuck out and really carried the information in the genetic code. So I would say it has something to do with building up the strand or the backbone. It helps to package DNA. No, histones do that. Histone proteins do that. It helps to hold the backbones together. Yep, sure does. That is exactly what it does. It binds to the nitrogenous bases. No, the sugar binds to the bases. And it is the genetic information. No, again, that's the bases that carry the information that needs to be decoded. So B would be the answer, something to do with the backbone. And it is correct. What type of bond helps hold a protein in a specific shape? It should be intramolecular bonds like hydrogen bonds or potentially disulfide bridges are the two that we talked about in our lectures. So carbon bonds, that's that's not even a thing. Ionic bonds, no. Hydrogen bonds, yes, definitely. And trochanteric bonds, that is completely made up, bogus answer. So C should be an easy answer on that one. Boom, got it. That's all we got. I believe there were 31 questions. So really, for every 3, you lose a letter grade. That's a pretty harsh test, right? So if you miss 3, that's an A. If you miss 6, that's a B. If you miss 9, that's a C. And we won't go any further. How did you do? If you need some help figuring this out more, go check out some of the prior videos. They really do help figure out this information. I'll see you when we start the next unit on finally building a cell and getting into the concept of cellular structures, which I think is a lot more exciting than this chemistry business. What do you think? Put it in the comments. All right, see you next time. Bye-bye.